Chapter 11.7 is going to be our last section of this year that you're going to be learning right before we're doing our project. So what we have done is we have built up our skills of working with these rational expressions, which once again rational expressions are just fractions. And what we've seen are these fractions can be a little bit more complex than usual. So what we have are many terms over many terms, so a polynomial divided by a polynomial. And what we have been doing is we've been adding these, subtracting these. We've also learned how to multiply and simplify these, and now today what we're going to do is learn how to divide them. So our objectives are listed below. Please do look over those. These are the last objectives that we're going to have to hit before we move into our project. Alright, quick review on how to divide. So using long division, I'm going to be dividing 152 by 6. So this, you're going to think is old news, but we're going to be kind of applying this to the new skill that we're learning today. So long division would say that you're going to take 152, divide 152 by 6. So 152 is what we call the dividend. It's what's being divided. So I am going to put that in the box. We're going to chop this thing up and divide it into little pieces. So it's in the box, and the 6 is on the outside, and it's going to be the one that's doing the chop work. So it's the end of this 152. It's the dividend. So 6 goes into 15 how many times? We're going to be looking at this divisor and seeing how many times does it go into this larger number. So 6 doesn't go into 1, so you could put a 0 here if you wanted to. So then I'm going to move on to my next column. 6 goes into 15 how many times? Well, 2 times, because 2 times 6 is equal to 12. And when you do multiply, you're going to put them down here. I'm going to check to make sure that 6 times 2 does go into 15, and yes it does. And then we're going to subtract, so we're going to get 3. If 6 doesn't go into 3, then we've done good. Okay, so now 6 doesn't go into 3, so we're going to move to our next column. So I'm going to pull down that 2. We're going to ask ourselves, how many times now does 6 go into 32? You might have to do some guessing and checking, or you could in your calculator type 32 divided by 6. You're going to get 5 point something. So when you get that, you can say, well, it wholly goes in 5 times. Alright, checker once again is going to do their job. We're going to get 30 here. So then you're going to put that down below. So yes, 6 does go into 32 5 times. And we're going to subtract, and 6 doesn't go into 2. So now we're at the end of this. What we can just go ahead and do is put a remainder. And how we do a remainder, keep in mind, is if you have a remainder, you can just take that 2 and put it over your divisor. So 2/6. So 25 plus, and then if you simplified that, it'd be 1/3. 25 and 1/3. Okay, same thing if you had 3, let's say. Alright, same thing if we did something like this, 5 divided by 2. So if I asked you to do 5 divided by 2, this is my dividend. I'm going to put that in the house, and then we have 2. So if I hope you can see 5 over 2. You guys can all kind of simplify this. We've done this before. It's going to be that mixed number. So here 2 goes into 5 2 times. We would get 4, and then we would get a remainder 1. What we have always been doing is that 1 over 2. You just take that remainder and put it over that divisor. So I hope that's all not too new. So some of our vocabulary, just as a quick thing, the dividend is the expression being divided. It's the top dog or the first number. So when we're looking at something, for example, like this, 152 divided by 6, what we just did, this is what we call our dividend. We could have also written it like this, 152 divided by 6, there's our dividend. Okay, dividend. It's the one being divided. We also have what we call a divisor. It's the expression doing the dividing. So what I want you to be aware of is this would be the divisor. It's that 6. It's doing the dividing. But what I want you to be aware of is we're going to have problems like this now, where we have a squared minus 3a plus 2 divided by a minus 1. So same thing here, just like that 6 would be a divisor in those more simple problems that we're used to, this right here is our divisor. It's the second number. You could also write that second number or a second expression, and it's the one that's doing the dividing. So in other words, you could rewrite this like a squared minus 3a plus 2, and then the divisor is the one that's going on the outside. Okay. Okay. Long division. So now what we're going to do is long division. What I want you to do is write down these steps. Basically, we have 3 major steps that we repeat over and over again. We have what we call a factor. That's the person, or that's the job of how many times does the first term of the divisor go into the first term of the dividend polynomial. And it's going to be a lot like what we just did with long division in those good old-fashioned numbers, but what you're going to see is this is going to require a few extra steps. The checker is going to be where you multiply whatever that factor found by that whole divisor, and you do have to do the whole divisor. So the first term should check out right. We're once again going to do this. I think the example is going to be most telling. And then we have a subtractor and puller downer. Okay, so after you have factored, after you've checked, you're going to subtract and pull that next term down. So be sure to line up columns by like terms. That is important. So here is an example. I have this polynomial, which we call our dividend, divided by, this is our divisor. Okay, and I have set it up down here exactly as I want it. So here is your example. The factor, if you look back in your notes, that's going to be where you look at this first term of your divisor and tell me how many times does 1x go into 1x squared. So you might need to do a little bit of work off to the side. You're asking yourself, 1x times what is equal to 1x squared? So you want to, as the factor, right now what you're trying to do is determine what's that other factor. And it would be 1x. Okay, you could also, if you wanted to, 1x times question mark is equal to 1x squared. You could divide both sides by 1x, divide by 1x. What you're going to see is those cancel each other out, and your question mark, your unknown, is going to become just 1x. Okay, so that's what we just found there. Okay, so make sure I'm going to go back just because this is so very important. Be sure to line up columns by like terms. This is what I mean right now. So when we're looking at where does this 1x go, you need to put it in the column of 1x's. Okay, so this would be considered the column x to the seconds. Anything with an x to the second you would have put here. Anything with an x you're going to put here. Anything that's just a constant you're going to put in this column. Alright, so after the factor, the checker is up. And as you have in your steps, the checker is going to take what the factor did and multiply it by the entire divisor. So that's what I've done. And you will need to distribute because this 1x wants to multiply by everything that's in this group. So this is what we're going to get. Alright, and then the checker can also make sure that those line up. Do they check out right? And yes, they do. So I'm going to put that up there. And the subtractor is up. They're going to subtract that whole thing. Now here, the subtractor is the person that would probably make the biggest error. If you take 1x squared minus 1x squared, that's fine. You're going to get that 0, which is what you want. Be careful here, because when I have negative 7x, you're subtracting negative 2x. So this is where big red star on the subtractor. Okay, you got to be careful when you're subtracting this 1x squared minus 7x minus this whole chunk. Make sure you distribute that negative sign. So it's not only this that's negated, it's also going to be this. So what you're going to actually see here is we're going to plus, negative, and then plus because this negated everything. So that's where you're going to get negative 7x plus 2x. If you add negative $7 plus 2, you're going to get negative 5x. Subtractor is also the polar downer, so we're going to pull that down. Alright, repeat. We're back to the factor. So just like in the long division with numbers, now you're going to look at this and you're going to ask yourself, how many times does 1x go into negative 5x? So factor, you're up again. What's that other little piece? 1x times what is equal to negative 5x? So what we're going to get is negative 5. And this is a constant, so make sure you put it in the constant column. Okay, so now factor after factor, who's up? Checker. The checker's up. So we're going to take whatever the factor found, and keep in mind it's negative 5 that I should have up there. Negative 5 times that whole divisor once again is just repetition over and over again. So make sure you distribute. We're going to get negative 5x when we take that negative 5 times the 1x, but then negative 5 times negative 2, that's going to be plus 10. So what I'm going to go ahead and do, subtract that, and then just be careful, negative 5x minus negative 5x, that's 0. 10 minus 10, that's going to be 0 as well. So there we have it. One thing, when you are setting these division problems up, you need placeholders to represent a term for every degree. So remember when I was saying that columns, you have a certain column x squared and then x and then a constant. So I mean, what we're saying here, this is technically x to the 0, and remember x to the 0 is just 1. Anything to the 0 power is just 1. So that's when we have a constant in that last row. So what I'm saying is, if you have something like this, for example, what you're going to actually write this out to, your highest degree is 2. Where's your x to the first column? So you're going to want to rewrite this and reestablish it as x squared plus, and then how can we use or put an x to the first in here when there is none? We'll just multiply it by 0. Okay, so that is your placeholder. Technically it's 0, and we don't normally write it like that, but in this process of division we do want placeholders, and then plus 11. Okay, I have another one here. Try this one. Okay, once again we don't have an x term, so we're going to have x to the second plus 0x to the first, and then plus negative 25 if you want. If you had x squared plus x, for example, now you don't have a constant, and you want to have all of those columns represented, so you're going to have once again x squared plus 1x and then plus 0. Okay, so there's how you would represent all those columns. Okay, so let's do a number 5. All it says is to set these up so you actually don't have to do the division, but you need to make sure you set these up correctly. Okay, so when you're setting this up for long division, what you're going to have to do is, this is your divisor, you're dividing this by this. So this is what's doing the dividing. Okay, and this is what's being divided. So make sure you can establish those. So you know this is going to go in the box, but here is the thing. Once again, you need a placeholder. So here is my y squared column, okay, and then plus, here is where you would need a y, okay, but there is no y in this actual expression, so that's when you just multiply it by 0, and then plus 8, alright, and then here, this is alright, here's y to the first, and then a constant. Okay, so there is the setup. We could divide this if we wanted to. And I'm going to put a 0 here. This was not included in the problem, but I'm going to tag it on there as a placeholder. Oops, and then we have divided by m. Now here's the thing. I am going to say this would have come from, here is my dividend. It's what would have been in the top dog position. Alright, if you can think of a shortcut for this, that's great. We've actually kind of tackled something like this in the past. If you can think of some way of accomplishing this and simplifying this in another fashion, that's great, go with that route. However, I'm going to be using this route, and you're going to see that you're going to wind up with the same route. If you can apply old skills to solve this, then you're going to find that you get the same results. So here I go. I'm going to ask myself, how many times does m go into this first term of my dividend? And if you need to, off to the side, you can write m times what is equal to 9m to the third. And then there is where you would divide both sides by m. You would cancel one of those out. What you're going to get is that what is 9m to the second. Okay, so I am going to go ahead, and technically there should be a plus 0 here for a placeholder, so I am going to write that. So here, this is a degree 2. It has to go in the m to the second power column. So there I'm going to put that. The checker is up. I'm going to take what that factoring found, or what that factor step found, and I'm going to multiply it by my entire divisor. So don't forget to distribute. What you get is 9m to the third from multiplying 9m squared times m plus 0. Remember, this is actually going to cancel everything out. 0 times 9 is just 0, and then m to the second. I'm going to just hold that as my position. So 9m to the third plus 0m to the second. All right, here's the subtractor. Okay, these are just going to cancel each other out. You get 0. You have 4m squared minus 0m squared. You're just going to get 4m squared again. And then that subtractor's job is to pull out on that next term. So here I go with the next term. M, this first term of my divisor, goes into this new polynomial how many times? I'm going to go ahead and write plus 4m. Okay, because 4m times m is equal to this 4m squared. But then I am going to take that, and this is my checker. I am just going to go ahead and check that to make sure. So when you distribute, you get 4m squared. That's exactly what I wanted. And then plus, once again, 0 times 4 is just 0, and then we have that m there. So we have 4m squared plus 0m. So once again, you're going to subtract this whole thing. Those cancel out, you get 0 just like you needed to, and then you have negative 8m minus 0m, so it's just going to be negative 8m, and then you need to pull this down, so 0. Alright, last time we're going to have to do this. M goes into negative 8m how many times? Well, you would have to multiply negative 8 times m in order to get negative 8m. Checker is up. Negative 8 times m plus 0. Distribute that, you're going to get negative 8m plus 0. So there we have it. Okay, this we're going to subtract this. Negative 8m minus negative 8m, that actually turns this into a plus, and this is a negative. So this is just going to be 0, 0. So this is our answer. All right. Also, I'm just going to throw this out here. If you were to pull out an m from each one of those terms, you could have done that. You would have had 9m squared left plus 4m minus 8. Okay, if you distributed that back in, you would get exactly that. We have this all over m. These are constant factors. They're the same exact factors that would cancel each other out. You would have gotten this. So that was our old method that we used back in 11.3. But regardless of whether or not you remember that, that's not important because we have many methods of getting to the right answer. Put any remainders you get over the divisor and add to your result. Just like when we had 5 divided by 2, for example, that's what we do. We would do this long division process, and then if you have a remainder, that's okay. Just put it over that divisor. Okay, so that's what you're going to do in these problems as well. I'm going to do one last quick example. It's number 34. We have d squared plus 15d plus 45, and then we're going to divide it by d plus 5. I'm going to go through this quick. D goes into d squared how many times? D times what is equal to d squared? Well, it's going to be d. It would just be 1d. So check that. Make sure you get this number that you were aiming to get. When I distribute that, I get d squared plus 5d. Okay, so I have d squared plus 5d. So those match up, which is exactly what I want, because now when I subtract them, I get 0. 15d minus positive 5d would be plus 10d, and then pull her down, plus 45. So now here's the thing. D, my first term in my divisor, goes how many times into this new thing that we have found? We're back up to that factor position. We're going to do plus 10 and put it in the constant column. Distribute that. This is that checker's job. You're going to distribute that through 10d plus 50. So 10d plus 50. Now don't forget to subtract everything. So this is going to be 0. And when you subtract this, you get negative 5 as a remainder. Now it's okay if you get a remainder. Just up at the top, you're going to put plus negative 5 over d plus 5. That's it. There you have it.